China's DeepSeek has now been banned from government devices in South Korea, Australia, Italy, Taiwan, and a few other countries, and we all know the reason why. They consider DeepSeek to be a major security threat because of the risk of sending important data to China's servers. This could be the beginning of an AI war between China and the West, but in the midst of the AI warfare lies even more innovation, one of the latest being Cerebras. The company has been around the block for a while, having been founded in 2016. However, Cerebras has recently found a way to host DeepSeek's R1 entirely on US servers, which reduces some security threats that the United States could possibly face. But how is this new AI chip able to outpace Nvidia's GPUs in performance by such a wide margin? And what does this mean for us going forward? The ongoing AI war between the United States and China has led to rapid shifts in AI computing, the type that could redefine which companies control the future of artificial intelligence. DeepSeek's R1 model burst onto the scene about 2 months ago, and boy did it cause some real disruption. But here's where things get interesting. Cerebras Systems has now made it clear that GPUs might no longer be the best option for AI. But why is that the case? AI models have focused on generating text, images, and code based on patterns. However, with the DeepSeek R1 model, it's a little different. The R1 specializes in reasoning. For instance, instead of just predicting the next word in a sentence, the R1 model processes multi-step logical tasks, making it far more advanced than our traditional models like ChatGPT or Gemini. Just one problem though. Since DeepSeek was developed in China, it essentially means that any company using DeepSeek's API is sending data straight to Chinese servers. And because of the ongoing concerns over data security, government regulations, and geopolitical tensions, many businesses have been reluctant to use DeepSeek's R1. But for every problem, there's a solution, and in this case, it's Cerebras. Cerebras features uncommonly large chips that are particularly good at speedy inference, that is, running rather than training AI models. The new wafer-scale AI processor delivers 1,600 tokens per second, running DeepSeek R1 at speeds that Nvidia's GPUs simply can't match. The company claims that its hardware runs the mid-size 70 billion parameter version of DeepSeek's R1 model, 57 times as fast as what can be achieved on the fastest GPUs. For so long, GPUs were the backbone of AI computing, and Nvidia's chips dominated the industry, powering literally everything from ChatGPT to Midjourney. But here's the kicker. Although GPUs are so powerful, they come with a fundamental flaw. They weren't originally designed for AI inference. See, traditional AI workloads need a lot of memory bandwidth and ultra-fast data transfers, and since GPUs were originally built for graphic processing, they often struggle with these demands, leading to bottlenecks that slow down AI computation. As AI models began to grow even more complex, these limitations became even more apparent. With Cerebras, however, this problem gets solved. Instead of using clusters of smaller chips like GPUs, the company developed the world's largest AI processor on a single wafer-scale chip. This design effectively eliminates the inefficiencies caused by transferring data between multiple GPU units, thus allowing entire AI models to run on a single massive processor without delays. So how did Cerebras achieve such dramatic speed boosts? Cerebras inference is driven by the CS3 system and the wafer-scale Engine 3 WS3 processor, which delivers high performance and throughput without any bottlenecks. Let's break both of them down, one after the other. The CS3 is a compact system that offers high-performance computing, delivering results in minutes that would typically take days on large multi-rack clusters. The CS3 can deliver the performance of many graphics processing units in a single unit, reducing the need for multiple servers and ultimately lowering costs. Simply put, the CS3 is efficient and compact. With the CS3, researchers can test more ideas quickly with superior AI compute performance, leveraging performance gains and reduced power consumption. The WS3 addresses memory bandwidth challenges and is compatible with the OpenAI Chat Completions API, offering a lower-cost alternative to other cloud solutions with easy API access. By clustering the WS3, Cerebras creates scalable supercomputers, and with this technology powering Cerebras inference, they provide groundbreaking speeds for advanced AI applications. Here's what the WSE3 AI chip looks like. And here's how it stacks up against Nvidia's H100. When running DeepSeek R1, Cerebras' AI processor achieves 1,600 tokens per second. This is in stark contrast to the 28 tokens per second on Nvidia GPUs. That's a mind-boggling 57 times increase in speed. But here's the juicy part. All of this does not show that Cerebras' wafer-scale technology outperforms OpenAI's GPT-4 and other leading AI models across multiple key areas, including mathematical reasoning, complex question answering, and AI coding tasks. Here's what the Cerebras comparison table looks like. Grok is another company that specializes in ultra-fast AI inference and have since started to offer DeepSeek to their users. But as good as they are, Cerebras is still at least 6 times faster. With such a massive performance gap, what keeps me up at night is wondering how long it would take to get a response from Nvidia. The $600 billion meltdown and the instant market reaction that occurred at the end of January has shaken the confidence of some investors in Nvidia's dominance. However, many more believe that the full rewards of investing in Nvidia's stocks are yet to come. But if there's anything we can all agree on, it's the fact that GPUs might not be the best option for AI computing anymore. It's about time for some major momentum shift. For so long, Nvidia inadvertently made us believe that GPUs were the only viable option for AI workloads. However, companies like Cerebras are pushing the envelope with dedicated AI chips that are faster, cheaper, and more efficient. You can all but guarantee that if GPUs are no longer the #1 choice for AI inference, Nvidia's team will be burning the midnight candle, trying to find a way to pivot quickly. Otherwise, they might be at risk of losing hold of their long-standing monopoly in the AI hardware market. But as is the case in the AI world, it's always good to take many of these claims with a pinch of salt. In a recent tweet on X, we saw an in-depth critique on Cerebras, and here's a snippet that reads: Cerebras has built a chip that on paper reads like science fiction. Astronomical core counts, co-located compute and memory, breakthrough specs, and a promise of radical acceleration through dynamic unstructured sparsity. Beneath the glossy marketing is a different reality. The company touts its novel approach as a paradigm shift, but the trade-off is now palpable. Sacrificing dense compute power that conventional AI workloads rely on. Despite eye-catching demos and more world records than you can keep track of, there's a conspicuous absence of hard, benchmarked data like ML perf scores. This opacity left me wondering how the chip would perform when the rubber meets the road. Essentially, this first section explains that Cerebras is sacrificing dense compute power and that there is a substantial lack of practical benchmarked data like ML perf scores. So apparently, not all that glitters is gold. Let's continue with the tweet. At a staggering price of $2 to $3 million per unit, the value proposition becomes very questionable when compared to cost-effective alternatives like Nvidia's H100 series. I foresee even more pain when Blackwell ramps. It's not enough to show impressive numbers if they don't translate into tangible performance gains for customers at a cost that is financially sustainable. Reading this part of the critique, it appears to me that Cerebras might face scalability problems in their attempt to dethrone Nvidia from the top, but let's continue. Cerebras represents a paradox to me, an almost perfect intersection of truly visionary engineering and commercial impracticality. The technology is groundbreaking in many aspects, but in my assessment, a proof of concept, not a product yet. I am afraid without transparent, scalable performance data, its lofty promises could ultimately leave both IPO investors and customers disillusioned. I am of the opinion that Cerebras should cancel its IPO, raise private capital, and build a competitive offering. This is a tough one, and I'll admit I'm sort of hung up on what Cerebras needs to do at this critical point. Do you think the company should cancel its IPO and focus on developing more practical solutions? Let me know in the comments. Because it seems like no one has real data about Cerebras' performance. Other concerns are that Cerebras is very expensive for the performance it claims, and that it actually doesn't work as advertised. But let me know what you guys think. In the end, it all comes down to this. AI is moving towards specialized hardware, and the race isn't just about who builds the fastest models anymore. It's about who actually owns the infrastructure, who controls the data, and the country setting the rules. Data sovereignty is more important than ever. Tech giants like Google, Amazon, and Microsoft are also already developing their own AI-specific processors and are moving away from the Nvidia-dominated GPU ecosystem. But does Cerebras provide the solution? Only time will tell. It's been a busy couple of weeks in the artificial intelligence world, but you can tell that we're just getting started. It's gonna be even more intense from here on. You can keep up with all the action by hitting that subscribe button, and if you missed out on the AI heist China recently pulled off, why not check it out after this video?